Hey everybody, welcome and prepare to be amazed at just how easy it is to make what is right behind me a deployable web app using Streamlit. Deployable meaning anyone on the web can access it totally for free, and we can specify with parameters the number of neurons in our hidden layer. So this is about making a neural network. You can do pretty much anything you want with Streamlit, but that's what we're going to do is make a simple neural network that's adjustable based off of these parameters, as well as the number of epochs here. We can train any model, and as we just saw, we'd evaluate it. I'm not going to do it right now because it takes a little bit of time, but it's really awesome. So let's just jump right into it. Just to make sure you're not intimidated, here it's extremely simple code. The Streamlit stuff is ST, and we barely have any of that. And the rest of it's just TensorFlow code that you've probably seen before. And if you haven't, you're going to get to see that. So that's awesome. And in total, it's less than 50 lines of code, which is fantastic for how much it's actually doing. But we are going to start with nothing. So we're not going to have this app.py. We're not going to have this terminal running, and we're going to do it all from scratch starting now. So anywhere we need to make a folder, I'm just going to choose the desktop for fun, and I'm going to do Streamlit YouTube app. Okay. So in this folder, we are going to go into that, and I'm assuming you're on Windows. If you're not, then hopefully you're comfortable with your own like Ubuntu or Linux environment. But here, what we have to do is get started with a virtual environment. And so I type CMD up here after I go into the folder, and that opens our command prompt. And you should hopefully see here wherever your file system or wherever your folder is, we should be in that. And then we're going to make a virtual environment, assuming you have Python and pip installed. If you don't, go learn how to do that. It's not too difficult. But we're going to type py or python-m venv.env. So this makes what's called a virtual environment. It's where we're going to store the various libraries we're going to need. And the various libraries that we need, we could install them as we go, except I think if I remember correctly, it's going to be matplotlib. So we'll do .env/scripts/activate. That's how I must have missed something there. .env/scripts/activate. Okay, so we should see .env here to show that we're in our virtual environment. And then if we show pip freeze here, we should see really nothing, because that's saying what libraries are installed in this environment. We shouldn't have anything yet. Okay, so we're going to install them, and I know that we'll need to pip install matplotlib as well as TensorFlow. So we'll just start with matplotlib like that. We're going to do TensorFlow, of course, Streamlit, and I'm not sure if that pre-installs pandas, but we're going to need pandas as well. Okay, so the reason I don't really care too much right now, but what we need is if we ever run into errors, we can just install them as we go. But I'm going to start off with just installing matplotlib as well as definitely Streamlit. Okay, so we should see that as well. Pip install Streamlit puts that into our environment as well. And we're going to make a very simple Streamlit app right now. It's actually very easy to make something simple. So I'll show you how to do that. Okay, I'm going to use VS Code to do this. So really, any sort of environment where you're editing your code is totally fine. But I want to open our particular folder in some editor. Okay, so I'm going to choose open folder. Streamlit YouTube app, just open that folder so we can see what's in there, and there shouldn't really be anything in there yet. Okay, we have this virtual environment, but that's just going to be for storing our libraries as well as running the app when we're ready. So in here we want to make a new file, and it's going to be just app.py. And aside from files that'll be made automatically, that is the only file we're ever going to use. Okay, we're just going to shove a bunch of code in this thing, and we're going to do import Streamlit as st. Okay, and then we're just going to start off with st.title with whatever title we want, and we'll just say customizable neural network, and it's going to be for doing handwritten digits. Sorry if it's boring for those of you that have done MNIST handwritten digits a million times, but for those of you that haven't, it's going to be something new, and for those that have, it's just easy and it feels nice. So this is going to be our app so far, and we can just go ahead and save that. And in here, it seems to be annoyed and taking a little bit of time to get Streamlit. Okay, I have no idea why this is taking so long, but I'm going to leave that in the video because sometimes this stuff happens. So I'm going to do Control-C to get out of this and spam it a couple times. Control-C, and I'm just going to go into the folder and delete that. So get rid of .env. Okay, if that happens, I'm just going to do the same thing again. CMD python py.m venv.env, and then makes an environment, and then we're going to go into it. As with before, we're going to do .env/scripts/activate to activate that virtual environment. Again, we see this .env here to show we're in it. And then after that, we're going to pip install with dash dash no cache dir. Okay, so basically it was failing for me because it was cached, and we're going to start with Streamlit. Okay, that took way longer than I wanted it to, but anyways, here it is. So basically we should have in our app.py import Streamlit as st, and I should probably make this a little bit bigger so you can actually see that. View, appearance, zoom in. There we go. Okay, so you should see import Streamlit as st.title, whatever we want it to be. And then in our command prompt, we need to make sure that we're in our virtual environment that has Streamlit available. And then we can do Streamlit run, sorry, my cursor's there, Streamlit run app.py or whatever you happen to call that. Okay, so that's going to run, and this is actually surprisingly quick. So it's going to spin this up, and it's going to be like basically a local web server for now. And here we have just a title, and it says made with Streamlit. And later we can see here we can actually deploy this app. We'll need to set up Git for that, but it's not too difficult. So we have an app, okay? It does something already, and we could technically deploy that if we wanted to. But let's make something slightly more interesting. And we're going to do this mostly in Google Colab, okay? So before we get too into the Streamlit stuff, I just want to describe what we want to do, and then I'll show you how to do that shortly. So we had two parameters on the left before, two sliders, and it was one is the number of neurons for our hidden layer of the network. That'll make sense soon. And the other one was the number of epochs, which is the number of times we run through a data set. So for now, they're just two slidable numbers, and let's go ahead and make those just to do something cool in Streamlit right away. Number of neurons is equal to, so we're going to be able to get this back as a variable, is equal to st.sidebar. And that's why it's going on the left there, the sidebar dot slider, and so it's a slider. We're going to give it the name here that we want, and we'll do number of neurons in the hidden layer. By the way, if I sound sick, I'm actually just having an allergy attack. Number of neurons in the hidden layer, and we can specify the minimum and the maximum. 1 and 64 we'll choose, but they're fairly arbitrary. They just had to be positive numbers, generally integers. And the other one we want is num epochs. So the number of epochs that runs through the data set. st.sidebar, same thing, dot slider. And there's so many of these other different options that we could be choosing. We'll also make a button very shortly. So we'll do this, then number of epochs with different values. Let's make it maybe 1 to 10. Okay, so after we have those, let me just show you that this works. And let me just output back. We should be able to show if I just type something like this, the number of neurons is this plus num neurons. Okay, so what's crazy is it actually is going to output this this thing for us. Okay, and why was I thinking that works? That obviously doesn't work. Plus num neurons. Okay, so if we go ahead and run this again, actually if we just go into our web app, we'll see that the source file changed, and we can just say rerun. Okay, and we got a type error. It says can only concatenate, not int. And yeah, no, I knew that. I'm just being I'm just being silly. This has to be plus the string of that to get that concatenate strings. And then if we do this again, here we go. The number of neurons is 1. So clearly we're getting this, and it's updating this value. We can use that in our code. Pretty cool. And we could get it's doing the epochs as well, although we just didn't bother to print it. So now let's go to Google Colab and do quite a bit of coding for our neural network. Okay, so we're going to basically just solve the handwritten digits problem, but we're going to purposely choose a neural network model where it has this hidden layer in the middle that has, well, for now, let's just build one with, say, 32 neurons in the middle. But we could specify this, and we could even specify maybe the activation function. In fact, I'll do that just for fun because I didn't do this when I was preparing this earlier. We're going to say the number of hidden layers, number of epochs, and the activation for that hidden layer is whatever we want. We can pick between, we'll say tanh and reolu. Okay, so if these don't make sense to you, don't worry about it too much and just enjoy a nice Streamlit app, and it doesn't really matter too much. Actually, since I decided to include this new activation thing, which is going to be a string, let's go ahead and add that in there just for fun now. So we'll get the activation, or middle activation, and this is going to be a string, is equal to the st, sorry for my cursor being there, st.sidebar, and then text input. Okay, we can see display a single line text input widget, so that sounds like what we want. We'll do that, and it's probably going to be, yes, the label is going to be a string, and let's make it, so what do we call it? Activation, just activation function is fine as a string. Okay, so we'll do that there, and then we'll say the activation function is, and we don't need to add string to that, it's just going to be activation, and good to go. Okay, so let's just make sure that that works. Here's our app rerun. The activation function is, we'll type something like Relu. Okay, press enter, and there you go. That'll update it like that, and that'll allow us to change the activation function as well. So pretty cool. So I'm kind of trying not to show off my own skill. I'm trying to show off the fact that it's so easy to just kind of figure out how to do something very quickly with Streamlit. It's really awesome. Okay, so for the Google Colab stuff, this is going to be for making our machine learning model as well as doing the graphing part. Okay, and we'll convert that stuff to Streamlit later, but let's just go ahead and do the code for now. And so we're going to get our imports out of the way. It's going to be a bunch of TensorFlow stuff. Import TensorFlow STF from TensorFlow.keras.datasets. We're going to import the MNIST dataset from TensorFlow.keras.layers. We're going to import all of them just for convenience. We're obviously not going to use all of them. From TensorFlow.keras.models, we're going to import sequential with a capital there. And finally, from TensorFlow.keras.callbacks, we're going to import the model checkpoint. Okay. So now what we're going to do is just load the MNIST handwritten dataset, and we do that with xtrain and ytrain, xtrain, ytrain, and xtest and ytest is equal to mnist.load_data. Okay, pretty standard procedure for getting the MNIST dataset. And so basically, if you don't know what it is, xtrain is going to be a NumPy array that has the shape of 60,000 by 28 by 28. So we have 28 by 28 images here. And although we won't actually include this, and so I'll make sure to say do not include in Streamlit, and actually you probably could and it would be just fine, but we're not going to for style. Do not include in Streamlit. We're going to do import matplotlib.pyplot as plt, and then we'll do plt.imshow the xtrain sub 0, and that is the first of 60,000 images. This is a 5, and so we're going to be making a machine learning model that tries to take these inputs and guess what they are. And so what we saw at the very beginning was an accuracy curve, or two accuracy curves, train and validation, or basically train and testing how good the model is on unseen data, the accuracies there. Okay, so we're going to make this model that does this. Pretty standard procedure is to do a pre-processing, where it's actually just going to be something called standardization. So we'll do define pre-process image, and that's going to take in like a set of images that looks, something like this. And all it's going to do is just return, so it'll say images is equal to images over 255. The maximum value is going to be 255, and we return images. Okay, that's all it does. And then we're going to immediately call this for xtrain is equal to pre-process image of xtrain, and xtest is equal to pre-process image of xtest. Make sure if you do actually mess something up and happen to run this again, that you are in every time dividing it by 255, and so it kind of gets messed up there. Okay, and so let's just make sure. Let's test for fun. Xtest.shape is going to be 10,000 28 by 28 images. So here we're going to make our machine learning model, and so the point of it is to learn from this training input in the training labels here. So each of these labels here, let me just show you that ytrain, and I'll place it there. Ytrain is just, it says what each of the numbers are. Okay, so we're trying to teach it that given all the inputs, or given a picture, we're going to try and map that to what the label is. That's what our model is trying to do. Okay, so we're going to make the model here that does that, and so it's going to be a Keras model. We'll do model is equal to sequential with model.add. We're going to give it an input layer, and the reason we can actually, I haven't loaded this in like explicitly, but I did this through the layers star here. So these are all the layers we're going to see. So we do model.add an input layer where we give it the shape of the input, and that is 28 by 28 images. So we're just going to write it like that. Get careful about the brackets. There we go. We'll do model.add flatten. Okay, maybe not the best thing. If you're familiar with making a model, you probably don't want to flatten it just yet, but it's going to be fine. We can make a neural network model that'll do just fine. We'll do model.add dense 32, that's 23, and here it's going to be, so these are going to be variables, so we'll change this easily. In our Streamlit app, we're going to change these values to what they are, so num neurons and the activation, that's what we're going to change there. And just to be, actually no, this is fine, so we'll remember to change those. We're just going to train one now on here, and that'll form the foundation of the code for when we put it in Streamlit. So we'll do model.add, so dense 32 ReLUs, so that's our hidden layer, model.add dense 10, and then model.add softmax. And basically what that does is we did 10 here because we have 10 classes, 10 different digits, 0 to 9 is 10 digits, and then we do softmax, which converts all of the outputs here, all the 10 outputs, to the probability of that corresponding class. Okay, so after we build the model, we do model.compile, and we compile it with the loss is equal to, since we didn't do anything with the outputs or the labels, we do this with sparse categorical cross entropy with metrics is equal to the list of accuracy is all we really care about for now. That's fine. So then we'll do a model.summary just to make sure this works, and that probably won't output properly in Streamlit, so that won't be included. But here's our model. So it takes in 784. Well, actually, it takes in, I don't know why it doesn't show it, but it takes in 28 by 28 images, converts that or flattens that, basically stretches that into 784, and then it converts it to 32, which is going to be variable, so that'll change depending on this slider right here. Okay, and then we convert it to 10 things to get our output class, and that'll allow us to make predictions very easily. And we'll never actually have to convert the fact that it's from probabilities and like take the maximum value or whatever. Keras is going to do that implicitly for us. Now we're going to set up some checkpoints before we do some training. So we're going to do CP, and that's really for saving the model. So actually I'll do save CP. Save checkpoint is equal to model checkpoint with model. And we'll do save best only is true. Okay, so we're only gonna save the model that has the lowest validation loss or the highest validation accuracy, most likely. And then we'll do history. By the way, the model here, this is just the directory I specified. We'll make a folder that puts model, and that'll also on our Streamlit app when it's right in there, it's going to make a folder in that in there for saving the model. Okay, so we do history. We don't actually we're never actually going to load the model again, by the way. This is just good practice. So this is going to be for saving our history, which is going to be the loss curves or the accuracy curves. We'll plot those later. That's what'll come out of the, oh, I got rid of it, but the evaluate model part, it would be there when we made that graph. And so history CP is going to be tf.keras.callbacks.csv logger. Okay, and I guess I just realized I could probably convert this to this exact thing, except instead of model checkpoint, actually, what is it? No, it's fine. That's fine. I'm going to leave it. Okay, so tf.keras.callbacks.csv logger. So this is really just when we're saving each epoch or run through the data set of the model, it's going to be calling this saving checkpoint, maybe, or saving function, maybe it saves it, depending on the loss, maybe it doesn't. It's also going to add to this CSV we're going to make, which logs or stores the loss or the history. We'll see this shortly. So we'll call this. What do we want to call it? We'll call it history.csv. It'll store it in that file with the separator equal to a comma because it's a CSV. And then append is going to be false, which is actually by default, so I don't need to write that. Now we're going to fit the model. So we do model.fit with xtrain, and ytrain. And validation data is equal to x test, and y test. Okay, so all I'm saying here is fit the model based off of this training input, try to map to that training output, and the validation data is basically, it's really just test data, but it's saying how well we're doing on data that it hasn't seen for training, and we'll input it like that. Okay, we're also going to specify epochs is 5, and this is also where we're going to specify it's going to be changed based off of this value right here. So epochs is 5, and callbacks is our callbacks. Okay, so callbacks is equal to the list of just save CP, and history CP. Okay, so call our checkpoints every time. And I will probably watch this with you because it shouldn't take too long. On co-op, it actually seems to be faster than my computer, which is phenomenal given that I have an RTX 3060 graphics card in this thing. So clearly they're using something better than that, or I have something messed up on my machine. But it trains very, very quickly. So we can see the accuracy of the training set continues to go up. The validation accuracy, which is what we actually care about, because we care about performing inference or guessing about data that we haven't seen before. And so this is going up, which is great. And we saved every single time, hence our save checkpoint doesn't really matter because the val accuracy went up every single time, which is why we saved every time. But anyways, we saved the model to model/assets. It happens to be there if we want to load from it, but we're probably not going to load from it. And history.csv. We're going to do that's going to store our information for the loss. Okay, and we'll actually we'll see that very shortly, actually now. So we're going to do import pandas as PD, as well as import matplotlib.pyplot as PLT. It knows how to do that. So we're going to get this thing I've called history is equal to pd.read CSV of history.csv. And then we'll make this thing called a figure. So fig is equal to plt.figure. This is just going to be a plot. And we're going to plot the validation accuracy as well as the training accuracy through epochs. So the epochs is going to be on the x-axis. Both accuracy curves are going to be on the y-axis. And this is how you do that. So we'll do plt.plot with the history. So basically we loaded in this history into a data frame in pandas, and then we're going to plot it with history sub epoch, okay, like that. That's going to be the x-axis, and then history sub accuracy. And actually I'm just going to run this for fun just to make sure. If we output just history.head right now, we will see that we have a table where we have the epochs, the accuracy, which is the training accuracy, the loss, which is the training loss, the val accuracy, and the validation loss. Okay, so I'll get rid of that as we don't really need it, but just to make sure it loaded properly, that's good. So we'll carry on with making our figure, and we'll do plt.plots with epoch, history sub epoch, that's wrong, and history sub, there we go, with just the accuracy. Okay, so we have that, and we're going to just copy this exact same thing. This will make another curve, or basically a line, for the val accuracy. If I do it like this, to make the val accuracy, and we'll just give it a title. So we'll do plt.title, and we'll give that something like, model accuracy versus epochs, which is just basically times through the training set, times through training. And then we're going to do plt.ylabel is going to be accuracy. Okay, and it's basically a percentage, but that's a little bit obvious. If it's not obvious, then basically we're just saying this has got 96% of them correct. Okay, so accuracy, and plt.xlabel is going to be the epoch or epochs, and we do plt.legend with, we specify that we have train and val. That says our two different curves in order, and the location that we want for it is probably fine. And here we're going to do plt.show but in Streamlit, we actually end up converting this to we're just going to write fig instead. But here we have our curve, so we can see model accuracy versus epochs, accuracy on the y, epochs on the x, and this x-axis is going to change a lot depending on that parameter we give here, the number of epochs that goes all the way up to 10, and we can see both of them go up and up over time. And you might even have seen, if we did a bunch more epochs, that validation accuracy started to go down. It's a little bit weird, by the way, that validation accuracy starts higher than training, but I mean, is what it is. I guess that's fine. And yeah, so that's phenomenally everything. Pretty much the entirety of the code. So if we look back at our Streamlit app, what we have so far, it's just a couple sliders, and we actually said what these are here, but we don't really need that. We know it's working. So what we're going to add quickly is a button to control, or we're going to add two buttons that control different control loops. So it's just, if you want to train the model, we'll click the train model button, and if you want to do evaluate the model or show that curve, then we'll put that in that piece. So we need to put these in buttons, otherwise it keeps training the model over and over again, because this thing keeps looping over and over again, and we really don't want to do that. So what we'll do is if st.button, and we'll give a label here, is going to be train the model. Okay, and just for now, we're going to put in just something simple, but we'll add actual code soon. Nothing more than what we already added. So we'll just say, actually, we don't even need to do that. We'll just say we are training. We are training. We're not actually training, but we're writing we are training. And if st.button, we have something like, what did I say before? Explain? No, let's just say plot the loss curves, or plot the accuracy. I said evaluate the model. Okay, so evaluate the model. We'll do that. And then we'll just write something like we are evaluating. Okay, so we have that very simple thing like that. And if we rerun our Streamlit app, we can do either train the model, which is we are training, or we can do evaluate the model, we are evaluating. Notice that the other one disappears because we loop it and the other one does not run. Okay, so we train the model, and then that model is trained, and we have to have stored some information there, either being able to reload the model, or at least load relevant data from the model. And we chose the latter, as in we ended up saving. So what we did here, and did this on purpose, is that we save into the CSV the history, so that when we train the model, we have it in a history, and then we can go ahead and load that after. So I skimmed over this quickly when we were doing it, but this is a really important concept, is that, you know, we saved something, we trained the model, and we never want to have to do that again unless we actually want to train a model again. So we saved everything that we needed. We chose to do it into a CSV that we can just load, and that's going to put that on the computer there. It's going to put that file there, and we can read from that whenever we want to. Okay, so after we did that, we can actually make this real code. Okay, and for this, I'm going to put these side by side. So it's really just going to be a bunch of copy pasting, but make sure that you watch what to do here, because it's not too difficult. But basically, we do want to put our imports in here because we don't really want to do it unless we have to. And I know it might be a little bit of a weird concept to see imports in this spot for once. But generally, we put them at the top, but here it's actually a pretty good idea. So we'll do the imports here, and then we'll load our data. Notice that this is actually downloading the data every single time, and that's fine. We could technically store it on the machine, but that's not too big, so this is fine. But something to think about for your own project. We don't care about opening the shape. That was just for us. We said do not include, so we're not going to do that. We do need our pre-processed image, so we're going to put that right in there. It's a little bit tricky. Sometimes copying and pasting does this weird thing with the indents, so I'm just pressing tab to make sure the indents are right. Maybe clean this up just a little bit. There we go. We don't need to show what ytrain is. We do need to copy all of this stuff for making the model. That's very important. We have that in there. It's still getting annoyed by the tabs, so I'm going to put it right there. Model summary, we really don't need to show. That was just for us, so that is fine. Here, remember, this is where we change the number of hidden layers and the activation here. So we should have this as num neurons. That's how we That's how we get the parameter. And here, the activation is going to be it's just called activation. Okay, so we have those strings in there, as well as epochs. We're going to see that very shortly when I copy these next three. Sorry about that. Copy these next three in here. Sorry, it's looking a little bit spazzy sometimes. And now here we have epochs is going to equal we wrote it as num epochs. So that's how we control that piece right there. Num epochs. And now we've trained the model, and that's really all it does. So it trains the model, and it automatically is going to do that CSV logger thing where it puts all of the information onto the machine. So let's just make sure that we can run this. So we're going to save it, and hopefully we don't run into any errors there. I don't really know if we will either. If we go to our app, we should see rerun and train model. Well, these things should show up. So we'll do something pretty simple just for speed purposes. We'll do just 4 neurons and maybe 2 epochs, as well as a ReLU activation is pretty standard. So we input those, train the model, and it says no module named TensorFlow. Okay, there you go. I actually forgot about that. So what we need to do is Control C out of this thing in our command prompt, stop running that, and we need to do pip install TensorFlow. Okay, I'm also, so TensorFlow is done. I'm also going to need pandas as we saw. So pip install pandas, and yeah, okay, so here we go. I think that's everything we'll need to run this this app. Actually, I guess we don't even need pandas yet, but we will soon. And here, so it's not running. Let's actually close that down and just run up. So I can press the arrow up button a couple times, which gets to Streamlit run app.py. So hopefully going to put it right into this browser here, and yes it does. We can see again some number of neurons. We will do say 4 with the number of epochs is 2, and the activation function is going to be actually let me just try tanh this time just for fun. Enter. Okay, so we do that, train the model, and now we can see it's running. So when it's deployed, you're probably not going to be able to see the actual output that's happening at the time. But we can see in the background what's going on here. So as we can see, the training process is happening in here. We probably could end up showing this on the app if we wanted to tell the user anything or any sort of training process in intermediate steps. But here we go. So it trained, and that's really all we're going to see. That's all we're hoping it would do. We didn't ask for anything else, so it's fine. It says connecting here, which I don't know why, but trust me, it's fine. I think I canceled it by accident, so it's not running anymore. And yeah, so the model trained, and now we're ready to do the other piece. Okay, so after train, it's really just as simple as this, except as I said, I think I said, we're going to change this last part, to just fig, because we just want to output it. So in here, evaluate the model. Yes, we are evaluating. We get rid of that. Tab that over. Okay, and here we go. Okay, so history epoch, that should be good. It should all be right. I'm not sure if I installed matplotlib yet. I forget. Pip install matplotlib, and we'll do streamlit run app.py. And so we'll train the model with something like with maybe 3 in the hidden layer, with, I don't know, just 2 epochs is fine. And again, we'll do a tanh activation function. So we'll first train the model. Okay, so our model has been trained, and just to evaluate the model, we can see, and I'll just pull up the big screen, here's our curve. Okay, so train and validation is again higher, which is kind of weird. It should be backwards, but anyways, that's how it works. And we could make a more complicated or better model if we added more neurons in the hidden layer and ran more epochs, and maybe change the activation function back to ReLU or something else. And to deploy it, I'm actually not going to show that to you, but I will explain it very simply. All you have to do is go to deploy this app, and what it's going to say is that it's unhappy that there's not a Git repo attached to that. So what you're going to have to do is just make a GitHub account if you don't already have that. But basically, I use GitHub Desktop. After I go to github.com or whatever, and I make a repo for this, I make a repository, I can then go into GitHub Desktop and clone that repository. That'll put a folder on my computer somewhere, and all I need to do is just move these pieces over to that, and then push that to the repo. And you generally don't want to push the .environment to the repo, because generally you actually do something else, which I'll show you just now. Is you don't that's just for making the environment. And so instead, what we do is pip freeze. I believe it's just this one, pip freeze, I don't know what to call that, requirements.txt. Okay, so after we do that, that makes this folder, which basically just says all the stuff we saw before, all the different environments, what it needs, or all the different libraries, what it needs to install. So we generally ship over, even model you probably don't need to send over, history you don't either. The main important ones are going to be app.py and requirements.txt, as long as those are in a public repo, and then as long as you run from the command prompt, you need to make sure that you run this command prompt with the virtual environment in the folder that has this Git thing. So when you download the Git stuff, that's going to put this .git folder onto that folder, and so we move this stuff into that folder. So we need to make sure to be running it. We'd have to have this thing. It would look something like this, like .git, and then we would do cmd and activate our virtual environment, and then it would work once we do deploy the app, and then it goes through an email process, and you can check that out. It's not too difficult from there. Hopefully that helped, and if there is something you need, maybe I can help you out there, but hopefully I explained the process there. And if you didn't want to listen to mine, or if that confused you, then hopefully you can find out somewhere else how to do that. It's pretty easy, eh? It's pretty awesome. Streamlit's great, and yeah, if you liked it, please drop a like, subscribe if you're not, and yeah, I'll see you in the next video.